Hello everyone, this is a continuation of the previous video that found a z-score and also the probability of selecting a single subject from the group and what the probabilities were less than, greater than, or between. This example is going to be a slight modification of that. We're going to start with the same values, given the mean of 120 and a standard deviation of 20. But we're going to take a sample size this time of 5. We're going to select 5 people at random or 5 objects at random to test and find the probability for, as opposed to the previous example where we only selected one subject. Here we're selecting 5. And what we're going to do is we're going to find the mean of those 5. And we're going to ask ourselves, and what is the probability of the mean of this sample of 5 being less than 105, being greater than 105, or, and I want to change this one, being, I'm going to change that slightly. So I'll do it that way. Okay, so what we do is we're dealing with something different. We're not dealing with an X this time. We're dealing with what's called an X bar, because we're talking about the average of the 5 subjects, not a single subject. And so we have to do some modification. We're applying what's called the central limit theorem. We're using the same formula we used in the previous example. We're using the normal distribution function. So we start with equals normal distribution. Since I want the probability of less than 105, exactly the same that I did before, I'm going to put in the X value, in this case the X bar value, which is 105. I'm going to put in the 120, which is the mean. But notice what I'm writing for the standard deviation. I am writing not just 20, but I'm writing 20 divided by the square root of 5. Now you can do that as a separate calculation and then put the results in there, or you can actually have the Excel do the calculation for you. I chose to have it do the calculation. And then a comma, and then 1. But notice that I'm doing 20 divided by the square root of 5. That's the modification that needs to be made when you have a sample of more than 1. This time I come up with a 5% or 0.04. Okay. Again, for greater than, I need to do 1 minus that value. So I will put in the 1 minus. That's the only change I'm going to make in the formula. Normal dot distribution, 105, 120. But then again, my standard deviation needs to be modified by the square root of 5. Now this one I need to do some little work on because I did make some changes. When you find the larger number, you're going to start with the larger number minus the smaller number, because remember, these are two areas that overlap. Both less than, the function gives me both less than, so I'm going to take the larger one minus the smaller one. And I need to make some modifications here because I did change some numbers. So the larger number is 125, so I'm going to put in a 125 there. But again, notice I've modified the standard deviation to read 20 divided by the square root. That's called the standard error. And over here, I'm going to change this, my lower number is 105, and so I'm going to put that in there. Again, I need to modify the standard deviation and come up with the standard error in order to do this problem. And then I'll press enter, and notice I get 67% between these two. Okay, so exactly like the other probabilities, except now we're talking about a sample size of 5 rather than a sample size of only one person. And that makes all the difference in the world, and it changes our probability substantially. Thank you for your time.